Hello all, good afternoon. In today's class, we will be discussing about kinematics part 2. Part 1 was about concept revision and formula revision. In part 2, we will be discussing practice problems. It will be of level 1 questions, level 1 type questions, also known as P1, that is priority 1. Basically, in ATC exam, for physics there are 30 questions. From my analysis, it's divided into 3 types: 10, 10, 10. 10 questions will be like basic, 10 questions will be intermediate, and 10 questions will be advanced. So today's class will be focusing on P1 type, that is priority 1, also called as level 1. It can be basic level questions or beginner level questions. So as our classes progress, whenever we get time, we will do P2, P3, if possible P4. P4 will be like sure questions, previous year questions, most important questions, which is of paragon level type. So let us proceed ahead with the class. First question. A particle starts from origin at time t is equal to 0 and moves along the positive x-axis. The graph of velocity with respect to time is shown in the figure. What is the position of the particle at time t is equal to 5 seconds? Okay. So we know that velocity v is equal to ds by dt, right? Where this is the position, right? Also called as displacement, right? So what is s? S is equal to integral v dt. So we have learned in integration, whenever we want to find the integral of a closed surface, the figure which is shown right here is a closed surface. We have to find the area enclosed inside the surface. So here in the question, if we want to find the position of the particle, which means we have to find the area of the closed surface. Okay, that is position of particle equal to area of the surface at time t equal to 5 seconds. Area of surface at t is equal to 5 seconds. Okay. So let me draw the graph once more. Let's see this. Then to firstly it is going to here, right? Then just going to here, then it's increasing to here, and then it's going to here. This much is enough. I'm drawing till 5 seconds because we just need to find till 5 seconds. Okay, the triangle part is over till where 2 seconds, right? And here we can see that this is a square part. This is 2 to 4, and also here the corresponding is 2, and here the corresponding is 3. So if you want to find the area of this entire closed surface, we can divide it. That is, this can be written as A1, A2 and A3. The sum of these three areas will give us the area of the closed surface, which in hereby gives the area position of the particle at time t equal to 5 seconds. So we need to find A1 first. So what is A1? It's a triangle, right? Half into base 2 into 2, right? 2 cancel, just equal to 2. Okay. Second one, what is A2? Right, A2. A2 we can say it is a square. See, because here 4 minus 2, 2. What is the height? Height is also 2. So it's a square. All the sides are equal, right? So A2 equal to 2 into 2 is equal to 4. Okay, A3. A3 is like a rectangle. So what is this? 4 minus 5, 1. What is the height? 3. 1 into 3. A3 is 1 into 3, which is equal to 3. So what is the position of the particle? Position of particle at t is equal to 5 seconds equal to A1 plus A2 plus A3, which is equal to, what is it? 2 plus 4 plus 3. 4 plus 7, 2 plus 9. 9 meter. So this is the answer. Okay, I forgot to give the options. So the answer is 9 meter. Okay, so let us move on to the next question. Okay, a particle travels one-fourth of the distance with constant speed of 5 meter per second and remaining distance with the constant speed of 80 meter per second, average speed of the car. Okay, good question. This question is related to the average speed. I have written many formulas pertaining to average speed yesterday in yesterday's class, right? So this formula was also written. So let me first show the diagrammatical representation of this question. From that you will be able to understand. Let's say this is the total path. Okay, total path travels one-fourth of the distance. Let the total distance be x. Okay, particle travels one-fourth of the distance. One-fourth of the distance means x by 4, right? X by 4. The remaining distance will be what? X minus x by 4, 3x by 4, right? 3x by 4. Okay, when it travels one-fourth of a distance, the constant speed is 5 meter per second. Here the constant speed is 18 meter per second, right? Okay, now we need to find the average speed. We know the equation of average speed when the distance and time is given, which is total distance by total time. What is the total distance? X, total by total time, t1 plus t2. T1, what is t1? T1 is equal to x by 4 into 5, right? That is distance by speed. Similarly, what is t2? 3x by 4 into 5. Simple. See, x by 4 into 5 plus 3x by 4 into 5. Okay, we can cancel off these x and all. Okay, it will be like 1 by 20 plus 3 by 20. Okay, it will be like, after substitutions and all, we will be getting the answer as 10.9 meter. 10.9 meter per second. That's the answer. Answer is 10.9 meter per second after substitutions. Okay, so this is a very simple question. If you know the concept and how to apply the formula, you will be able to solve it. Let us move on to the next question. Okay, very good question. This question has been asked in various exams. Okay, most of the people will be thinking it's like a JEE level question. Yes, it was a JEE level question, but once upon a time it has been asked in AAITC as well. So it's a simple question actually. Okay, we just need to be aware of the concepts. Okay, a particle moves from A to B as shown in figure. Then the ratio of distance and displacement will be. Okay, as per the definition of distance, I have told you that distance is the length of the path. That is the actual length of the path. In this figure, in this circular figure, we can see the point from A to B. What is the actual length of the path from A to B? This is the actual length. That is the arc length. I'm drawing a rough figure. Okay, arc length. So in trigonometry, we have learned like what is the equation for arc length? Arc length, comma L equal to r theta. Here what is r? Is given question, capital R, capital R. What is theta? 120 degree. Okay, so distance is equal to r into theta 1 into 120 degree. We are going to convert to radian. Why? Because in the options we can see most are written in terms of pi. So I'm going to just convert to radian. R into 120 into pi by 180. Okay, 0 0 cancel, 6 2s are 12, 6 3s are 18. So we'll get like 2 pi r by 3. Okay, note it down. Okay, now we need to find the displacement. It's quite a tricky process to find displacement. Okay, just let me just draw the figure once more. A, B is at an inclined point. Okay, here it is here and it will go till here and it is covering subtending an angle of 120 degree. Okay, we know that displacement is the difference between the initial position and final position. So I'm drawing here. Let's assume this point is P. Okay, this x, the value of x, that is from here to here. Okay, this x is the displacement that we need to find. So I'm going to use the concept of isosceles triangle property to find x. So what I'm going to do is that I'm going to draw a perpendicular from here which divides the angle equally. That is, here it will be 60, it will be 60. Okay, in isosceles triangle we know that this distance and this distance is equal. So what I'm going to do is that I'm just going to find this distance. Okay, let me mark this point as O, this point as C, O, C, A, and I'm going to find this distance, and when I double it I will get the whole distance x, which is our displacement. Okay, we have this angle 60. Okay, this is our radius r. Okay, this is x by 2. Okay, let me give it as x by 2. Okay, what is sine 60? Sine 60 is equal to, instead of x by 2, I'm not giving as x by 2, I'm going to give as x1 for simplicity, or everyone will be multiplying 2 and all. Okay, x1. Okay, sine 60 is equal to what? x1 by r, right? So what is sine 60? Root 3 by 2. Root 3 by 2 is equal to x1 by r. And what is x1? x1 is equal to root 3 r by 2. Okay, I need to find x. What is x? X is equal to 2x1, because x1 equal to x2, because I'm dividing this as x1 and x2 such that x1 equal to x2, which means that x equal to x1 plus x2, which is x1 plus x1. I'm dividing x is equal to x1 plus x2 such that x1 equal to x2, which means that x equal to x1 plus x1, which is equal to 2x1. Okay, so that's how this 2x1 came into being. So x is equal to 2x1, which means that what? 2 into root 3 r by 2. Okay, 2 cancel, so x is equal to root 3 r. That is, our displacement is equal to root 3 r. So we have the distance now. Okay, that is x is equal to root 3 r, which is our displacement, which is equal to displacement. We earlier found distance. What is the distance? 2 pi r by 3. Distance is equal to 2 pi r by 3, right? So you need to find the ratio of, like, this is equation number 1, this is equation number 2. As per the question, we need to find the ratio of equation 1 by equation 2, right? What is the ratio? 2 pi r by 3 divided by root 3 r. R and r will be cancelled, 3 will be going down. So the answer is 2 pi by 3 root 3. This is the answer. Let me check the options. Yes, we have in the options answer C. C is the answer. Okay, let us move on to the next question. Okay, the angle between velocity and acceleration during retarded motion. Okay, during a non-retarded motion, during a normal acceleration, if the velocity is going in this direction, acceleration is also going the same direction. Okay, this is uniform acceleration, but in the case of a retarded motion, the acceleration will be in opposite direction. That is, velocity is going to this like 0 degree, the acceleration will be in the opposite direction, that is 180 degree. Here will be the acceleration. Okay, for retarded motion. It's a very simple thing, just understand the definition of it. So the answer is B. Okay, next question. The numerical value of ratio of instantaneous velocity to instantaneous speed. Yesterday I have written the formula of instantaneous velocity and instantaneous speed such that the formulas are equally identical. So the answer of this question is always equal to 1, because it's nothing but like instantaneous velocity, numerical value. Okay, instantaneous velocity I'm written as IV by IS. So instantaneous velocity V instantaneous. What is V instantaneous? Is equal to limit delta t tends to 0 ds by dt. Instantaneous velocity, whereas is the displacement, whereas this is also limit delta t tends to 0 ds by dt, where here s is considered as the distance for speed. This is speed. V instantaneous, s instantaneous, I'm going to write. Okay, this is here, this is distance, and here this is displacement. Okay, so we can cancel it out, it will be equal to 1. Okay, always equal to 1. So answer A. Next question. Okay, now let me just explain some theories based on this question. Okay, I'm going to explain the options one by one, and finally I will tell the answer. Okay, for a moving body at any instant of time, option A. What is option A say? If the body is not moving, the acceleration is necessarily zero. Okay, we can't say that because that is false actually. The reason is because let's say I'm throwing a ball vertically up. Okay, when I throw a ball vertically up, okay, at the highest point it is at momentary rest. Okay, this is the highest point. When it is momentary rest, v or u is equal to 0, right? But the acceleration g still acts downwards, right? The acceleration will never be 0, because even if I throw the ball at the highest point, the ball will have a tendency to come down, which means the acceleration g is acting downwards. That is, there is some acceleration acting on it. The acceleration will not remain 0. So A is wrong. Okay, option B. Okay, option B. If the body is slowing, the retardation is negative. If the body is slowing, the retardation is negative. Okay, a slowing body always has a positive retardation. Okay, a slowing body always have positive retardation. The retardation will never go negative. It can go negative, but not for a slowing body. Okay, for a slowing body, you can write as point. Slowing body has positive retardation, not negative retardation. It has positive retardation. Okay, so this is also wrong. Let's go for the C. C. Distance traveled is always positive irrespective of its motion. Okay, yesterday I have explained the same point. See, if the body is slowing, the distance is negative. I have told you displacement can be negative, 0 or positive, but in the case of distance, it's always positive. So you can write a point like this: distance traveled is always positive irrespective of its motion. Option D. If displacement is u and t at instant are known, we can find the displacement at any given time in future. Yes, we have this relation s is equal to ut plus half at square, right? If s, t and acceleration a is known, if s, u, t and a is known, we can find if displacement, velocity, acceleration, not time. Okay, we can find a particular quantity called t here. Using this t, we can find the displacement at any given time in future, right? With the help of this t, we can find the displacement at any given time, right? So D is correct. So for this question, option D is correct, whereas rest of the options are contradictory. So by knowing u, a and s at any instant like t is equal to 0, we can determine x, that is displacement at any time t. Okay, these are all theory questions. Just understand the concept, that's enough. Next question is a very good question. Okay, a stone falls freely from rest and the total distance covered by it in last second of its motion equals the distance covered by it in the first 3 seconds of its motion. The stone remains in the air for. Okay, so first we have to find the unknown factor. What is the unknown factor? Time, right? We have to find the time. Okay, so here is we have to know two formulas. One is the second equation of motion, just s is equal to ut plus half at square. Okay, the next formula is distance traveled by the nth second. Sn is equal to u plus a by 2 into 2n minus 1. Where we use this formula is by reading the question. Look, total distance covered by it in the last second. For that we can use this formula. Last second covered by distance traveled at the nth second. Nth second here in this question means last second. For the first 3 seconds we can use this formula. Okay, second, understand? Okay, so we in this question, which is here, it is given by Sn, distance traveled the last second, is given by distance traveled the last second. I'm denoting it as Sn. For the first 3 seconds, I'm going to denote as like S3, okay, equal to S3. Okay, this is what it is given. So distance traveled in the nth second. Okay, so here by the question we can see that a stone falls freely from rest. Freely from rest means what? U equal to 0, initial velocity equal to 0. So we can modify the equations, right? Sn, what happens to Sn? U will become, here U will become 0. We can already take these three terms, a by 2 into 2n minus 1. Instead of a by 2, what we need to give g, because it is falling during free fall and all, a is converted to g, right? A equal to g during free fall. Okay, so we need to write like this, g by 2 into 2 into n means nth, that is tth second, t minus 1, which is equal to, this is ut plus half at square, this becomes 0, half gt square, that is half into g into t square. Here what is t? 3, so into 3 square, right? So g and g will be cancelled, 2 and 2 will be cancelled, 2t minus 1 equal to 3 square, right? 2t is equal to 3 square, 9, 9 plus 1, 10, 10. T is equal to 10 by 2 is equal to 5 seconds. See, simple question. Just apply this formula. We must know where to apply this particular formula. Here, last second means nth second. Logic. First 3 second means S3, second equation of motion. Just equate the both. U becomes 0 because of what? Falling from rest. Then equate both, a will become b because it's a free falling body. That's why instead of n we can give t, and for this t we have to find, because we have to find the last second, right? This t is already given, we can substitute it and we'll get the answer. Answer is this 5 seconds. So the option is B. Okay, it's a very good question. It's a sure question for AAIATC 2024. Let's go to the next question. Okay, I think I actually left space for this question, but I was able to manage within one page, so no worries. Okay, this is a good question. It's quite complex. Okay, since it's a complex question, I'll explain the last. Let's go to this question. Okay, the distance traveled by a body along a line time t is proportional to t cube, that is s is proportional to t cube is given the question. Acceleration time graph, we have to find the AT graph. Okay, that is we need to find the relation between a and t. Okay, first of all let us find velocity. We know that velocity v is equal to ds by dt, right? So it is equal to d by dt of t cube, so it's equal to 3t square, right? So now we have velocity v is equal to 3t square. Now we need to find acceleration. A is equal to dv by dt is equal to d by dt of 3t square, right? Is equal to 60, right? So now we can see that a is equal to 60, which means that a is directly proportional to t, which means that a increases t, which means that t increases, a increases, and t decreases, a also decreases. For directly proportional, the graph will always be like this. I have taught you yesterday, a and t, it will be constantly increasing like this. So the option is B. It's a very simple question, just apply that concept. So this is a 2012 question which is asked in JEE Mains. Okay, you might not believe, but it was asked in JEE Mains, also asked in various exams like KEEM, BITSAT, SRM, etc. SRM. It hasn't been asked in AAIATC yet, so we can expect this question for AAIATC 2024. Because mostly when students see graphical type questions, they are confused like which graph it will be, or whether they will think that they haven't studied this particular graph. No worries on that. Whatever data is given, with that data, with the help of equations, solve the data, find the relation between the unknown terms and configure a graph from those relations. Okay, let us go to the next question. Okay. So this is the second last question, guys. Okay, a particle moves a distance x in time. according to the equation. Okay, x is equal to 1 by t plus 5. Okay, the acceleration of the particle is proportional to. So we need to find a relation between either acceleration or velocity, or acceleration versus displacement. Okay, so let us figure it out. So first of all, let us figure out the equation of velocity in terms of t. So v is equal to dx by dt, right? Dx by dt, which is equal to d by dt of 1 by t plus 5, which is equal to minus 1 by t plus 5 the whole square, right? And with the help of this, we can find the equation for acceleration as well, right? A is equal to dv by dt, which is equal to what? Minus 1 by x square. When we differentiate it again, what will we get? Minus 2 by t plus 5 the whole cube. Those who know differentiation can understand this properly. For those who don't know, please go through the chapter of differentiation and integration and all. All those chapters will be explained by concept classes along with problems and all in the upcoming classes. Okay. Minus 2 by t plus 5 the whole cube. Okay. So now we don't need a relation between a and t actually. Why? Because it's not given the options. But we need to establish a relationship between either a and b or a and d. I think a and d is literally not possible, because we have 1 by t plus 5, distance square, distance raised to minus 2. It's not possible. Okay, the only possible way we can go for is velocity. So let's do one thing. I'm going to write like this. A is equal to, in terms of v, I'm going to write, okay, let's write that minus 1 by t plus 5 the whole square. This is actually v, but when I add some particular terms here, I can make it in the form of a, right? So I have to add 2 here. I have to include 2 here, not add, include 2 here into 2. Okay, but it's cube here. I can give like this. No, sorry, I don't need to give like that. Sorry for that. 1 second. Okay, for here I can give like this. A is equal to minus 1 by t plus 5 the whole square. In order to include 2 here, it's better I give like this, 2, and in the bracket I'm going to include 3 here. The only way to include 3 is like this, 3, and we have to cancel off 2, so we can give this 2 in denominator. Okay, now we can write a in terms of v like this, minus 2 what is minus 1 by 2 t plus 5 the whole square, v, right? Plus 2 v raised to 3 by 2, right? So acceleration is directly proportional to v raised to 3 by 2. Let's check whether that's in the options. Yes, it's there in the options. A. So the answer is A. Okay, now let us move on ahead with the last question. Okay, this is actually a tricky problem, but it's quite understandable. Okay, a particle is dropped under gravity from rest at a height h. Okay, let's assume there is a building with height h. This is a building. Okay, the particle is dropped under gravity. Okay, here there is a particle, it's dropped, it's free falling. Okay, from rest from a height h, and it travels at a distance 9h by 25 in the last second. Okay, let's assume this is the ground level. Okay, this is the ground level, and this is the last second. Okay, for last second the height becomes 9h by 25. Okay, we need to find what is the height h. Okay, that means in the last second of fall, what is the distance it covers? It covers a distance of 9h by 25. Okay, that is h will be changed to 9h by 25. okay, in the last second of fall. Okay, at time t, okay, at time t, the height is what? H, right? At time of last 1 second, what is the height? Height is 9h by 25. Okay, now what we need to find? We need to find when the particle is dropped. That means we need to find the height. That is, we have 9h by 25, we have h. We need to find the height when it is free falling. So we can find like this. That is, this much is, assume this much is free falling height. Okay, this much is free falling height, this much is 9h by 25, this much total is h. So we need to find t minus 1 second. Okay, t minus 1 second. T minus 1 second means total t second, 1 second. This is t minus 1 second. T minus 1 second is the time taken for free fall. For t minus 1 second, the corresponding height will be h minus 9h by 25. Okay. 25. Okay. Now let us write in top. Okay, the continuation is in top. Okay, here we know that s. What is the equation for s? Ut plus half at square. This there is no relation, there is no equation value for u is given. It's also coming from rest. See, in question it is mentioned rest, which means that u, this thing we can cancel. That is u is equal to 0. So s is equal to half at square. Since it is a free falling concept, we can proceed to s is equal to half gt square. Okay. Now let us go to the next thing. Okay. So first time t, at time t, at time t, we can write h is equal to half gt square, right? This can be given as equation number 1. Okay. Now at time t minus 1, okay, t minus 1 is the time during free fall. Free fall means here dropped under gravity, so I'm just referring that as a free fall. Okay, t minus 1. So for t minus 1, no need to mention as free fall. Time t minus 1, you all know what is it's dropping under gravity. Okay, time t minus 1, the corresponding h becomes what? H into 1 minus 9 by 25 equal to half into g into time changes to t minus 1. T minus 1 the whole square. This is equation number 2. Okay. Now we are going to divide equation 2 by equation 1. We need to cancel out many of the things, right? Equation 2 by equation number 1, which gives 1 minus 9 by 25 equal to t minus 1 the whole square by t square. Okay, I'm going to take just simplify. Let me just simplify that. It's just 25 minus 9 is 16. 16 by 25 is equal to t minus 1 the whole square by t square. Implies I'm just taking the square root on both LHS and RHS. Square root on LHS and RHS. Okay, we will get like, what is square root of 16? 4 by 5 is equal to t minus 1 by t, right? 4t is equal to 5t minus 5. Okay, what is 4t minus 5t? Then we will get the t is as 5 second. Now we got the t, but do we need t? No. What we need to find? We need to find h. Then we can use the help of the first equation. From first equation, h is equal to half gt square, right? Half into g, we can either take 9.8 or 10. Okay, so since in the question it's mentioned to take g is equal to 9.8, we must give 9.8 only. Okay, if it is not mentioned in the question, we can give as 10. 9.8 into 5 square. So after substitutions, we will get the value of h as 122.5 meter. Okay, so this is the answer. Let me check the options. Yes, B is the answer. B is the answer. It's a very tricky question, just know the concept. That is, when it is dropped under gravity, we must consider this particular height. That is, h minus 9h by 25 is this particular height. And with this particular height, the corresponding time will be t minus 1 if the total time is t. And this is the time with the last 1 second. Last 1 second. Okay, so it's a very simple question. It looks complicated at first when we keep on solving and all, but at last it will turn out to be very simple. Okay, so this is all regarding the practice problems of kinematics part 1. Soon there will be videos on part 2, no, I mean part 3 and part 4, and if we have time I will also teach you part 5, which will consist of previous year questions, most important questions, sure questions, all those things. And there will be marathon sessions when physics 11th physics is completed, which will consist of a lot of questions from different chapters of class 11th. Then mega marathon, which consists of both 11th and 12th physics. Then mega marathon of both physics and mathematics, and so on. Okay, hope you all understood and like the class. So please like and subscribe the channel for more videos. Thank you guys, have a nice day.